Thanks for joining us. This is the ESIP IT&I CDI Tech Stack Working Group. Today we have rOpenSci presenting. Stefanie Butland and Carl Boettiger are going to be giving us an overview. We also have a couple others, including myself, that are going to kind of give a little bit of background on some of the work that's been done recently. Next slide. All right. So for those of you that don't know anything about rOpenSci, the group really promotes open and reproducible research using shared data and reusable software. This is a technical community that has a number of participants. They drive the use of R, the development of R packages. And the connection here with USGS and ESIP is that ESIP has hosted several fellows that have produced R packages with rOpenSci sort of serving in an oversight role. The products that they have produced, one of which was recently presented, that was Mike Mahoney, who really developed a package that connected the R user community with the USGS elevation data services stack. So really kind of enabled those native R users to come in and use our services to produce these really compelling visualizations. And we're really grateful for rOpenSci, ESIP, and developers like Mike Mahoney. We'll go to the next slide. And so Stefanie and Carl are going to give us an overview, but I wanted to also give a little bit of information that might connect us to the tools that rOpenSci has. The package that I just mentioned, Mike Mahoney's package, Trainer, the services that USGS provides. So these are the national map services that Mike Mahoney makes use of and leverages in his package. And then a couple others. So we worked with Scott Chamberlain and Carl and the rOpenSci group on TaxID, which is a popular package that leverages the services that our integrated taxonomic information services provide. And again, another package that lets those R native users connect to some of the services that we provide out to the public. With ESIP and USGS, there are opportunities for us to take advantage of some free or subsidized resources. So there's ESIP Lab that provides cloud computing access and grant funding. And our USGS CHS, which is a little bit more of a limited forum. So for USGS staff and affiliates, you can actually utilize the RStudio Connect environment, and that's been provisioned by our cloud hosting services. The contact for USGS staff would be Courtney New. Next slide. And with that, we're just going to jump into the presentation. I think we've got Stefanie on, and she's going to go ahead and stage her slides, and we'll be rolling with the actual presentation.
Thank you.
Thank you, Stefanie.
1 minute. Just getting myself queued up. I learned something from Megan already today. Enter full screen. There we go. All right. Thanks for joining, everybody. My name is Stefanie Butland. I'm the full-time community manager for rOpenSci. I came to this work about 5 years ago as a reformed research scientist and low throughput bioinformatician, but I could never resist connecting people with each other and helping people recognize the value they bring to a project. So that's what brings me here. I got really excited when I saw Derek's invitation to present, because I recognize some of the people on the CC line that are part of this working group. And so Laura DeCicco, for example, I met when she attended 2 rOpenSci unconferences in the past. She's reviewed something like 4 rOpenSci packages, and now she's an associate editor for software peer review. She'll be talking to us a little later. On that CC line, I saw Megan Carter and Leslie Shee, who I know we worked a little together in January 2019 during their initial fellowship it was a community engagement fellowship in which I was a mentor at the beginning. So we got to know each other a bit there. Mike Mahoney is the author of the Terrainer package that we know just passed software peer review, so I know him virtually. Carl is an rOpenSci co-founder and continues to be a strategic advisor for us. And Scott Chamberlain, who a lot of you know because he has created so many incredible R packages for rOpenSci that so many people have used his stuff. So he was a co-founder of rOpenSci, no longer staff, but his work lives on. And Derek had mentioned that they worked together on a USGS core science systems data challenge that they won. And this led to this R Bison package that we still have that gives access to biodiversity information. So the reason I raise this is because I'm excited about talking, because to me, community and the work we're able to do together is all built on relationships. So this presentation is just an opportunity for all of us to get to understand each other a little better. We are going to try to do a little poll first because I don't have a good sense. For example, have you ever used an rOpenSci package knowingly, attended a community call? So Megan, can you try to send the poll? There it is. We'll just take a few moments. And I don't think, I don't think I have to go on forever. Something like 19 people have answered. Have you ever used an rOpenSci package? Something like 30% of the people say yes. Some people have probably used packages but don't necessarily know they're from rOpenSci. Have you attended? Maybe I'll end the poll because I think that way I can share the results. Yes, right. And then, have you attended an rOpenSci community call? This is actually cool to me. Everyone says they haven't. So this is one of my low barrier ways for people to get exposed to rOpenSci stuff. And I'll tell you about that in my presentation. And then the other, have you participated in rOpenSci software peer review as an author, reviewer, or editor? So I know Mike has, but everyone else says no, which again is actually kind of cool because this is some of the stuff that we're going to share with you today. So I'm going to stop sharing that poll. And I think I'm going to close it. And this is great because it just gives me a sense of where folks are at. So I'm going to ask Megan to put a link to this doc in the chat. And what I've done is I've created a shared doc that we use in our community calls so people can add their questions there as they come up during the discussion, because we want to know what it is that you want to talk to us about or ask us about, things you don't understand about rOpenSci. So it's more important that we address questions that you're interested in. So please go in there, add your questions. I have also added links to every single resource that I think all of us are going to talk about, and we can add other things too. So you don't have to take any link notes during the presentation. It should all be in that doc. So with that, I will tell you that as a beginner level R user, it would be too much of a stretch for me to pretend to give you a deep dive into which packages I think are ideal for USGS applications or how you might take advantage of some of our other platforms. But instead, I'm going to point to each of these things, and then I'll queue up Laura to talk about software peer review. I know Carl is keen to talk about, hear about what your goals and challenges are, and he's keen to talk about technical issues of data interoperability, and so he'll chime in a bit later. So I invite you all to ask us the hard questions because together as a group, we're up for it. So rOpenSci was founded in 2011. We create technical and community infrastructure for open and reproducible research in the R language. And we feature a curated collection of over 300 R packages. We've got a rigorous yet friendly software peer review system for community contributed packages, the R Universe platform for building, testing, and publishing R packages and documentation. And we build community engagement programs around these to support scientific R users and developers. 10 years ago, when rOpenSci was founded, the R landscape was a very different place. And this is the kind of vibe that most people associate with rOpenSci. So back then, the infrastructure for developing packages was quite sparse. RStudio had only 4 employees. And back then, people typically had to develop their own packages as their needs came up. They developed their bespoke solutions, but if someone else wanted to repeat what they did, they'd have to develop their own code. So rOpenSci was created in part to fill that gap, and initially provided about 4 or 5 tools. And over time, we worked with people in the community to develop others as the needs came up. So in this way, rOpenSci became a bit of a clearinghouse for packages for a lot of people. So over time, the ecosystem in general got richer and more accessible, and it was a lot easier for people to develop their own packages. So our focus shifted from providing users, with a different tool for every data source and making that our role, to helping people build their own by developing and sharing standards. So these days we're best known for this software peer review system we have, and what we call our dev guide to creating and maintaining good research software. And we continually iterate on these things in response to questions and open issues and pull requests that are submitted by people in the R community. Most recently, we launched a statistical software version of our software peer review system and a whole new infrastructure platform called the R Universe that Carl will fill us in a bit about. So from the first blog post ever from rOpenSci in 2012, first UnConf in 2014, and the first of many community calls in 2015, rOpenSci has been a community-oriented and responsive organization. And I really found my dream job when I joined 5 years ago to help build a community of practice around these processes and platforms. All of this work is done by these lovely people who together make up the equivalent of about 5 full-time staff. So to get into the meat, I think I already mentioned that we have something like 300 curated community and staff contributed packages. So this is a snapshot from our packages page on the site. I'll note that on every one of my slides, I've got a pointer to what the URL is, and this will also be in that shared doc. So here, different categories of packages. Oops, pardon me. If you were to click on the data access category, you'd find yourself with something like 120 different packages for data access. And here I've got a screenshot of what it looks like if you click on geospatial to get to the geospatial packages. So I point out here Mike Mahoney's TerrainR package. So if you were to, you can search by package name, you get yourself to TerrainR, view the documentation, takes you to the docs page. That's sort of a rOpenSci consistently branded pages. This takes you to vignettes. Also has the link to the GitHub repo where all of this stuff lives. And part of my role I see as getting people attention for the work they're going above and beyond to do. And part of that means when someone's had a package pass peer review, I will sometimes invite them to write a blog post about it to share their perspective a little bit differently. So Mike contributed a post. And then when this is up, we tweet to our 30,000 or so followers to try to bring more attention to the nature of the work and the people who are doing this extra work. So at some point we decided it was a good thing to start soliciting use cases from people who had used our packages because we knew people were using it, but like who and how many people are using things. And so now we've over time developed a nice little system for bringing attention to these. So this is a screenshot from the use cases page on our website. We have over 100 use cases now, and we have a simple template. So you go to our discussion forum linked in the bottom. There's a simple template that asks you to add a few things to share your use case. And then these are tweeted weekly, and we tag both the package author and the person who shared their use case. So again, bringing attention to them on top of us knowing how people are using the software. So use cases that have an image associated with them are fed to our website, and these things are searchable, and the website link is at the bottom of the slide. So this is a great example. So the use case is the targets pipeline with R Markdown to download and visualize USGS data. So this was submitted by Lindsay Platt for USGS data science. And on the left is a screenshot of what it looks like when the use case appears in the public forum, and people can comment and discuss these things. And on the right is what it looks like when weekly, I think on Wednesdays, we tweet these, again, tagging USGS data science, as well as the targets package author, Will Landau. So this is my cue to draw attention to the targets package. So part of Lindsay's Stefani's quote here was, I decided to use targets to build a pipeline that could handle skipping downloads that were already successful if I needed to start again. And this is one of the keys of the targets package. Laura has mentioned that she recommends this to a lot of people for developing workflows. And Will does outstanding work. This has been a big success story for rOpenSci, for Will in particular, but we're lucky that he passes his packages through review with us. And he has notoriously wonderful, rich documentation, videos, written, diagrams, everything. So highly recommended, and kudos to USGS and Lindsay for sharing this use case. This is my cue to ask Carl to unmute for a second and tell us just a little bit about his rUniverse and the rUniverse platform, if you don't mind.
Great. So rUniverse is something that's also been developed out of rOpenSci. Jeroen Ooms has been the lead developer here. I'm not speaking about it in terms of like as the developer or creator of the rUniverse, but really as kind of just one of the many profiles it can create. So many of you may have worked with packages from CRAN. rUniverse acts kind of like a CRAN-like system, but it's designed to be a bit more sort of open and distributed. So it can do the things that you can do with CRAN. You want to be able to install packages with pre-built binaries directly from the internet. It can help you do that, but it can also connect all of those packages through GitHub. And so we can get different versions of for your different software that without kind of the friction that some people have maybe encountered with CRAN. I won't kind of go too deep into that. I then wanted to kind of use this as a sort of jumping off point to say just a couple of words about like some of the packages that I've worked on in rOpenSci, as sort of part of the rOpenSci community that illustrates both the benefit of that kind of community interaction and connects to USGS. Derek mentioned at the top the connection with TaxIs and ITIS, the Taxonomic Information Service, and working with my collaborator Scott, who's really the lead on that. This another package I wanted to mention here in TaxiDB. Maybe I'll be bold here and take a quick screen share. If this is going to work, is that going to be okay? Looks like
I can unshare for a second.
No, I think it's going to let me seize the controls.
Take over.
Maybe you can see this.
It's small.
Let's make that a bit bigger. All right. And so what I'm doing here is I've just dropped here into the README for like the TaxiDB package. So if you've used ITIS or other naming providers, you know that this is a very important process in taxonomic resolution, that you want to be able to look up a name and know if you've used the sort of the correct form of the name or recognize synonym. And you know that different sort of scientific papers or anything sometimes will use sort of different versions of that same name. By mapping those names to identifiers, we can make sure that when we're combining data from diverse sources, that when we say a particular species, we're all talking about the same species. So ITIS is super important for doing that. And there are other catalogs that are important as well, from GBIF or Catalog of Life and so forth. One thing we learned in TaxSci is trying to speak to all of those different platforms. That was very classic rOpenSci. You know, we'd talk to these things called REST APIs. You know, you as the user would go and send up a little query to one service and a query to a different service, and each service kind of spoke its own language and gave you back the data in its own form. And that was very great and customized because you'd see each of those different resources, but it made it also somewhat difficult, both as a developer or as a user, every time you wanted to move from something like ITIS to something like the NCBI names or something like, you know, open tree taxonomy names. You had a new API to learn, a new interface, even within our interface itself, because they're speaking in different ways. The other challenge that we would often encounter with these APIs is we'd have researchers, including myself, we'd say, well, I don't want to look up one species or two species. I want to look at the whole darn corpus. I want to look at like all of the species and kind of get a snapshot of what's in there. Now, the REST API model is not really well tuned for that. And so you're seeing a shift now. There's an increasing number of rOpenSci packages working in this model of, can I access the whole data set directly rather than kind of bit by bit through everything as a separate API request. So to both illustrate that kind of broader concept and a little taxa example, I want to show this kind of quick example here. And so what I've done here is just kind of install showing you kind of the log, so you don't watch this in real time. I've just loaded the TaxiDB package, and it plays nicely with dplyr, so I've loaded dplyr here as well. The first thing I've done is say I want to import a database, and so here I've imported all of the catalog
Carl,
of life.
can you make that
that
bigger again? I'm old,
yeah,
but
let's see.
Yeah.
Thank you. All right, that may be too big. And you can see all I'm showing here is it took about a minute, almost 2 minutes to go ahead and create the full catalog of life. And it did this in 3,700,000 line chunks. So that's 3.7 million records of names. But once that's in there, it's kind of at my fingertips to go ahead and do stuff with. I'm going to do that now here up here in the R Markdown. And apologies for the kind of clunkiness of doing this live, but now we'll actually run some live code. So boom. So here I say td create. If it's already created, you run that again, boom, nothing happens. It says I've already got it. I don't have to wait at all. And so imagine you have some species list. Here I'm pretending I'm working with, say, bird data using just the standard bird species list from the breeding bird survey names. Now, as you may know, many of those names are not proper ITIS names. So here I grab those names and I try to resolve them here in catalog of life. This could be ITIS. I could just say ITIS. Everything works the same way, except accessing a different database, but the formats and the functions are all the same. I don't have to change my code other than that. And what I get back is I get the catalog of life identifier for the species when it's been able to be found. And of course, some of those names have names that are not recognized by that. I could get a different list if I just do ITIS. I could have ITIS IDs. If ITIS has not been imported, it'll do that one-time import, but it's going to store all of ITIS locally. ITIS is not too big to be downloaded, neither is catalog of life. Again, taxonomic names or order of a couple million records, right? And so here we can see many fewer of those names can resolve in that particular, in ITIS this time. I can also go the opposite here. So I can go from, I'm going to switch back so that my birds is catalog of life IDs for consistency. I can then say, can you turn those IDs into names? So here I say, here's an opaque identifier. Catalog of life has a prefix, everyone's prefixed, and then there's an identifier. And so, boom. I did that. I can get names, and here it says, oh, I can resolve the names. I don't want to go too deep into taxonomic things. I'm just going to pop back out and do a survey of some other topics that might be relevant, and then we can revisit any of these things in the questions. So other things that may or may not be of interest, pulling out from the R universe. There's been some great efforts that we have seen with ESIP developing metadata that's in the RDF format, in the resource description format, such as schema.org, also other forms of markup. Being able to work with RDF is something that was important to me within the R ecosystem. And so again, working with collaborators, we tried to figure out ways to do database interfaces to RDF. So this is a little vignette that I've called a Tidyverse Lovers intro. Yep.
Increase font, please. Increase size.
Yep. Thank you. Tidyverse Lovers. And so if you're familiar with Tidyverse packages, but you haven't worked with RDF data before, this is trying to make it kind of easier to kind of jump into that world. And we provide interfaces to some of the major databases like Virtuoso Connections, which were maybe less commonly used than like MySQL or sort of already available database plugins. And so you can do that too. You can play with RDF data. If you have no idea why you care about RDF data, we can talk about that as well in the discussion. Another thing that has been important in that ecosystem to me has been being able to move data objects around. Often intermediate objects, you have some big data file, but maybe it isn't ready to be like published, put in some permanent archive. You just need to make it available to colleagues, or you need to make it available to the world, but it's too big to say stick in GitHub. So we did this package called piggyback, which kind of lets that larger data file up to 2 gigabytes per file kind of sit on top of your piggyback as it were, on top of your repo. So basically the same concept as other formats like the GitHub LSF objects, large object stores. But I hope this one's more R-based, but also kind of less friction. We found that, for instance, using the large object store with GitHub's support for it, because of the financial model of storage, you can't like now be very open sourcey. Someone forks your project and all of a sudden they don't have access to that same thing. So piggyback is a little bit more lightweight way to sort of pass your data around, so that if it's too big to commit to GitHub. Again, you can kind of take a look through the vignette if that's a problem that you face, and maybe that's helpful. We've taken a quick look at TaxiDB. Part of that ecosystem as well, with data that's too big to fit on GitHub, was also data that's too big to fit in R. That's been kind of another common model with this, like, oh, instead of using the API, REST APIs, again, kind of the heart of many rOpenSci packages at first, we're in a way, one way to solve this, the data is too big problem. You speak to a server up on the internet and you get, the user just requests their little chunks. Well, increasingly we have more options, other ways to do that, right? One is, as TaxiDB does, it downloads the whole thing locally, but doesn't stick it into RAM. Classically, R wants everything to be in memory, and that causes problems with big data. Accessing external databases is a good way around that. TaxiDB is using that under the hood to make all of those functions very fast that I showed you. Making that more general is this package ArcDB, which is just designed to make it easy to move in and out of from a database format to a plain text format like CSV, where you maybe are archiving it for the long term. You want it in a text format, or you're given the data in a text format, but then you need to import it quickly into a local database for querying. And so it's designed to play nicely with that kind of back and forth. This is increasingly, you can almost bypass ArcDB in some of the newer versions of packages like supported by Arrow. I think there's some really interesting models now that are just kind of emerging for us, where you can even sidestep downloading those, say, a whole bunch of CSVs directly, and you can access them from your local R terminal without ever downloading them, and still being able to use your kind of friendly dplyr functions. So this was kind of an early version of being able to do that. There are other ways to do that now. I'd love to talk a little bit more about those as well, if that's of interest as we dive in. One more thing I'll just mention as we're talking about like accessing files and skipping the download. Stefanie mentioned kind of a common problem when you're writing code. You want to be able to put in a URL, but you don't want to have to access that URL every time that code runs. You'd rather that download were like saved on your file, right? And then you have to be able to move that code around, and it needs to know where it's going to get that data later on. So this Stefanie mentioned that Targets is a sort of full workflow solution to do that. This is another package called ContentID, which is kind of a lightweight way to just address the sort of one problem of how do I repeatedly reference a specific file in an R code. So we're used to doing that with things like putting in a big long URL. Every package can use that URL, but has to download it every time. You could instead put like a local file name. Let me sort of skip down to, I don't have an example of that. You could, I'll go live again, if that's okay. So we could say something like read CSV, my file, but of course this is not portable. We could turn this into a URL saying like some location. Of course, this might fail because the URL moves, or it might be just too slow because I have to download it every single time. So in ContentID, we take the approach of saying, well, I can store a URL once, and that's why I'll show you the example of it. So I can either register URL with a remote provider, or I can use the store command to store that object once. And instead of using the URL in feature, I have a unique identifier for that object. This works in a distributed fashion in the sense that like the computer can say, oh, look, I have this data already a local copy, and I know I have the local copy because that's the SHA-256 hash of the file. So I don't need to hit the internet. I don't need to download it from anywhere else. I'll use the local copy, and I'll know that it's not been accidentally overwritten or anything. So that can be very powerful to kind of skip the downloads. It will also be able to say like, oh, I have that data. I don't have a local copy anymore because you're running me on a different machine, but there are lots of places I can find that local copy. Let's do a quick example of that. ContentID, and I say something like, let's see what sources you have for this URL. Oh, I have the URL twice. For that ID. And I get back a table that says, oh, there are lots of places where this could be found. That same file is found on my local hard disk. It's found in the software heritage snapshots. It's found in the Zenodo archive. It's found in the ESID dive catalog of in data one. It's found at a data one address. It's found in SciDAC and so forth. So this is a famous ICE core data. So if it's not available from any one of those, it cannot, the computer can automatically try the next version of that. So if I want to load that file in R, I can simply say, just resolve this data. So you can think of this kind of like a DOI, except there's no need to publish the data and get a DOI. Anybody can have a content identifier as soon as you have a data, because it's just the content hash. So if that's of interest, we can talk more about that. So here now I actually have that file. I could, read. I forgot what kind of table that is. Well, looks like it's tab separated, so I forgot that. But anyway, you can see I've read in that data directly. So there's that classic with the header and everything, Vostok data table associated with that hash. Okay, I'll stop there and hand over to Laura.
Let me see. Oh yeah, so you've relinquished. Am I still screen sharing? I think.
No.
We are not seeing anything, Steph.
Oh, well, that's okay. So then why don't we let Laura go ahead? Yes.
Okay. I was just writing down Carl's package there because it looked cool and I hadn't seen it before, so that's cool. All right. My name's Laura DeCicco. Pronouns are she, her, and I work in Madison, Wisconsin for the USGS. I've made several R packages and got involved with rOpenSci. I didn't realize it was towards the beginning of rOpenSci, but now I learned that as well today. So I'm going to talk about the software review process, why you might want to do it, how that happens. I got a lot of the slide references from some other rOpenSci editors and staff, Gnome and Lael. All right, can you guys see this all right? The Zoom hides my text, so just had to check. Okay, so why would you do a peer review? Scanning through the list of participants, I don't think I need to convince anyone why peer review in general is good. It is a little different for software than it might be for something like a journal article. So software, software could change over time. You probably want to update some software as time goes on, whereas a journal article gets written once, you review it, you're done. It stays in that state for all time. So you do have to think about it a little differently than kind of the classic journal peer review. So why peer review software? It does drive the adoption of best practices and standards. I won't read these quotes, but both the people that are requesting a software review and the reviewers have given us feedback that the review process, I guess I will read it, has taught them a lot about making their code more robust and resilient to future changes. A lot of times, the people writing our packages might not be software developers, but they're scientists and they're building this software because they need to. In today's science, you got bigger and bigger data, you got to do it through a computer. But these scientists don't necessarily know all of these best practices. So this review process can be extremely helpful for both the developers and the reviewers just to learn these best practices. It's also in that same realm, it's increasing the quality of our packages, what we say here, and the long tail of the application. So this is the downloads, a snapshot of the monthly downloads of our packages. And there's some packages that are used by everyone. dplyr, as Carl had mentioned, you know, almost everyone who's using R probably has downloaded it on their computer at one point. But then it tapers off, and there's a lot of really good, really important packages that aren't downloaded by that many people, but they're critically important to certain science, for instance. The quality of those packages has historically been questionable. They might be amazing, they might not be amazing. And so having a peer review on the packages that, you know, even if your audience is a group of 10 people, that group of 10 might be solving, you know, COVID-20 or whatever we end up getting next. So they're important. And then we build a community of practice, and Stephanie's talked a lot about this, but having a set of people with the eyes on the package, talking, communicating, really nothing but good comes out of that. So what are the criteria for both submitting a package and reviewing a package? That's what this slide is here. So the review criteria, in order for our rOpenSci to do a review, the package has to be open source. If you're in the USGS, we are typically told to use CC0, which is open source, so we're good on that front. After that, there has to be complete documentation. So there's nothing more annoying than finding a package that's probably going to help you, but you just cannot use it because you do not know how to figure out how the functions work or anything. So our rOpenSci requires all the functions to have documentation. They require, you know, our rOpenSci requires all the functions, well, to have a high test coverage. So what that means is the package developers themselves have put these tests within their software that says, here's how I use the function, and then here's what I expect that function to come back with. So if that changes over time, the test will fail and we'll know something's changed. We got to either fix the function or let the users know that the behavior is different, something like that. Packages are supposed to have readable code. So it shouldn't be a question, you know, when another R developer looks at that code, they should understand what's happening. It shouldn't be very cryptic. And finally, the package itself, the software needs to have a usability factor to it. We should all be able to go in, read the documents, and then just generally see how easily this code works. And that gets fleshed out with the peer review. So if you write a package and you think it's working great, and then you go to the peer review and people are very confused, that's great. You've gone into the peer review. Now you can fix it and make it so people can use your code. Similarly, there's some criteria on our reviewers. So this is the second column, how to review. So maybe you want to sign up to be a reviewer. It's done in an open environment. It's done on GitHub issue public page. So everyone's going to see the back and forth communication. We want to make this process constructive for everyone involved. So I've got to say, I've watched over several reviews now. It's almost a joy to watch. Like there's very little gatekeeping. Everyone's trying to be constructive and helpful. And it's inspiring sometimes because you can see it in other communities where it's not that way. So, editors come in and make sure things happen, but there's been very little times when it's not been a very constructive, non-adversarial process. It's all done on GitHub. The review. So if you're in code, if you're a USGS person, for instance, and you do your work on GitLab, that's okay. The repo can be on GitLab. The review is done on this GitHub process. And the reason for that, I'll talk a little bit about. There's a lot of infrastructure built into these GitHub issues that makes it easier for the developer, the reviewer, the editor, everyone. And another interesting bit of the review process is it is ongoing until the package is accepted. So assuming the package has sort of passed the pre-checks of it fits within our rOpenSci's domain. So if it's like very narrow and it's only going to ever be for your one little group, that probably would be considered out of scope for rOpenSci. But if it is within the realm of what rOpenSci, accepts as packages, we will go through this review and work with the authors until their package passes this criteria. So there's no rejection. It's a continuous work until it's accepted, which I think is another positive, nice aspect of it. Stefanie hit on this, and I would say there's a development guide, devguide.rOpenSci.org. It talks about the development, maintenance, and peer review for our packages. It is fantastic. I've recommended this link to all sorts of people, whether or not they are planning to submit to rOpenSci. It talks about security things you might not think about. It talks about continuous integration. It talks about all of these things. It's got some really nice checklists, and rOpenSci values our volunteers' time immensely. So volunteers are asked to do the peer reviews. Volunteers are asked to be the editors. No one's getting paid to do these things. So we want to make that process kind of as seamless, but still useful as possible. So these checklists are great. I use them all the time. It starts out with just brief checklists, so you can actually run through and say, yep, it's got all these things. This is just a screenshot that I grabbed, but there are also more open-ended questions that really help walk a person through doing a technical software review. That includes this editor's template on the side. So those are great. Within that GitHub repository that does the reviews, there's been a lot of work lately on this rOpenSci bot. So review bot, I call them. I think they have a better name for them, but it makes all of the overhead and logistics that kind of go with organizing things so much easier. So if you want to just check the package, you just ask this little review bot to check the package, and it says, thanks, I will, and it does it. If you need to assign reviewers, you hit that, and it does a bunch of things on top of just tagging a reviewer. It gives them some information, it gives them due dates, things like that. It's great. And then on top of that, there's this entire system on giving some automatic diagnostics to the package just instantly from that bot. So right away, if someone submits a package, they're going to get this feedback instantly without any volunteer time that says, these are all things that need to be changed in order to, for us to basically request reviewers to spend some time. So they'll go through, and the editor and the developer will kind of go back and forth until you get all these green checks. And so that's a really high bar already. And then we didn't even have to ask anyone to spend their own volunteer time to do it. So we've got checks, and we've got these diagnostic plots that help reviewers kind of navigate the package easily and quickly. So I don't want to spend too much time on this because again, I think you can all see the benefit of peer review. But finally, just another screenshot of this review process. It's a great, if you're ever looking for a good example of how to use GitHub issues, and GitLab is very similar looking, so you could also send people here. There's all the issues have really helpful tags. They're assigned people to kind of mediate things to keep them along. You can see at any given time, there's a ton of conversation going back and forth. And so if you're looking for examples of really interesting software reviews, good ways to organize your issue tracker, things like that, I would recommend going here. It's great. And that's all I'll say about software review. Other than, okay, I'm a USGS person. I know some of the, we've been very GitHub centric on the slides. We do everything in code.usgs.gov. That will work with our universe. One of my examples, I definitely tried it out. That works fine. You can submit rOpenSci packages from a GitLab repo, also not a problem. I've seen nothing wrong. This is, again, very specific to USGS with submitting a USGS package to get an rOpenSci review. from a policy standpoint. And in fact, if someone were to ask me, center directors for non-USGS people are the ones that are going to make the approval for software releases. And part of that approval requires a technical review. I can't think of anything better than an rOpenSci review to be used as your technical review. So I don't think it's been done like that, but I would strongly support that if someone wanted to try it as getting the review there. But within our own USGS software development cycle, like I said, I use this document, let's jump back up here quick, this guy here, to help people do my internal technical reviews in private too. So that's the software review overview, and I'll send it back if I can remember how to stop sharing to Steph. And
that was brilliant, Laura and Carl, like ideal. Thank you both so much. I am going to try to briefly say, let me see, 2 low barrier ways, and then we can get to questions. 2 low barrier ways if you want to get a little bit of exposure to our rOpenSci stuff. 1, we run community calls, usually 6 in a year, and sometimes they're deeply technical topics. So we just did one on this review bot called Buffy, and sometimes they're things like talking about governance model in open source software organizations, or debating about data repositories, where to put your data, how to deposit it, and tools for that. So community calls is one. We also do every month what we call social co-working and office hours. So we have 2 staff people attending all the time, a quiet room and a noisy room. The noisy room is where you can go and you can ask any questions about software peer review or our stuff that isn't even our rOpenSci stuff. But it's with a bunch of friendly people, and so you can kind of hang out and get your work done and also socialize a bit. On the Q&A, I'll pass it in a second, I think, to someone else who's going to moderate, but Abby had a question that related, Abby Benson had a question relating directly to Laura's comments. And I'll just read it here. With USGS incorporating software review as part of our fundamental science practices, is there an opportunity for us to use the rOpenSci review process to meet the needs of the software review that we're required to do? There's a +1 and some exclamation marks, and Laura already addressed that. The answer is yes, but I think let's just make sure that this is, the loop is closed. I would say, how to explore that.
Yeah, I would say it hasn't been done to my knowledge, but again, I talk with center directors and answer their questions on that scientific policy. So I would recommend it, but it would be up to your center director. But I think it would be a great way to do it, at least the technical review.
Thank you. And I think with that, I'm going to leave it to someone else, whether it's maybe Derek or someone, to read some of the questions they think are most relevant. If there's stuff we don't get to, each of us will try to type some answers in the doc after the call. So
yeah, I think that's a really good idea. So because we are running a little short on time, we may not be able to get to all the questions on the call. Go ahead and throw those into the document. I'm going to have Megan check the chat, and then I'll just go top to bottom on the questions. I'm going to leave my questions for last, and I'm going to jump right to Monica's question. Monica, can you come off mute? But I'm going to read your question. Can you link to GitLab? USGS uses GitLab for our packages that we want to publish through USGS. And Monica, if I missed anything there, just go ahead and come off mute. Okay. Stefanie, did you get that?
No. I mean, yes, you got everything in my questions. Thank you so much.
Okay, thank you. Thank you, Monica. Okay.
So I think it should be fine.
So connecting to GitLab.
GitLab is good.
Okay, perfect.
Yep.
All right, I think we covered Abby's question. We have one from Brett Longworth. So I was helping someone with so that's just it was helping someone with taxonomic names in R this morning. Tax size looks amazing. And so we've already got somebody who discovered a new tool that our rOpenSci helped to publish. I've got Rob Casey. Is rOpenSci responding to the DOE request for information regarding stewardship of software for scientific and high performance computing? This program really seems to hit the right marks for what they're looking for. I'm not familiar with that. Laura, Stefanie, Carl?
We're not doing anything that I'm aware of.
Mhm.
I feel like I saw this somewhere, but yes, and I'm not responsible for getting us money, but I'm not aware of it.
Will it be okay if I give a shout out
Yeah,
to your program? Because this is just a comment. It's just commentary on their proposal, and I might point to you guys because what I see here is really great.
thank you.
All right.
I'll pass this on to I'll pass it on to our project lead, Karthik Ram, as well, who would be the person to respond to it. Thanks.
Perfect. And then last question so far from Brett Longworth. How do you encourage people to attend your social core office hours? We have a similar open call at UI, but it's underused.
My favorite kind of question. I'll try to be brief. We have relatively few people who attend, but they end up being high quality. And so some people attend who have attended before, and they use it as part of their practice, like, hey, I need a little accountability to do that. So sometimes we'll have 8 people, but the things that happen during these sessions are remarkable. So there was one time we had 2 people calling in, or 2 people attending from Singapore. They'd never met each other before, but they had both been in different rOpenSci community calls. So again, it's very much about the relationships, and it's not necessarily like the volume of people who attend, but kind of what happens in the session. So we do run, we alternate months. So one month is 9 a.m. Pacific time, and then the following month will be 9 a.m. in Perth, Australia, to sort of satisfy different groups. But again, not very many people attend, but we might have like 8 people from 7 different countries at the time. And so that's what I try to focus on rather than the numbers. And we still find it really well worth doing.
All right. So I covered the questions that are in the document. Megan, are you seeing anything?
I'm in the land of leaf blowers right now, so I hope my audio is okay. But I see only some excitement from Mike Mahoney about just how great the review process was for Terrainer. I don't know, Mike, if you want to say anything more about that. I do not see any other questions.
Okay. Mike.
Yeah, I don't know that I have a ton to add here, but definitely want to echo that the review process really made Terrainer a much, much better product. It's very easy, I think, when you're developing this sort of research software to feel like you're off in the wilderness by yourself. And so even just getting extra pairs of eyes looking at the product and not just saying like, oh, well, this isn't the right way to do that, this could be done better, but also saying, oh, this is a cool thing you've got here, here's how it can be better, was just a really fantastic experience to go through with this.
And it looks like Leslie has a question. Leslie.
Hello, thank you. Okay, so I love, unable to stop. Okay, no problem. I love the package catalog, and I think that I've seen it in a previous state and it's kind of new. It has a new format. So I'm just wondering, is that homegrown? Is there somebody on your staff who has decided the best way to communicate what these packages are, and how do you do that?
My short answer is the people on our staff are amazing. So yes, we have like research software engineer, a software engineer, and yes, it's people deciding this is the best way. A lot of it is though suggestions from people in the community where like they attend a community call, and then they're maybe like go through software peer review and they're on our Slack, and people feel more comfortable and trusting that if they make a suggestion that it'll be listened to. Like just outstandingly talented, thoughtful staff who kind of watch what's going on out in the world of R and bring it back here. Also with the organization, somehow we have this amazing we have this way that we can sometimes take risks and say, well, we think this is a good way to do this, so we're going to do this. But sometimes it allows other people to go, oh, well, okay, maybe it's okay to do this because rOpenSci has done it. So, and we've survived 10 years, so maybe it's okay too. I don't know if Carl, do you have any other comments about awesome staff people or tech infrastructure?
The staff people are, yes, they're mind-blowing, but there's lots of ways that we distribute, and that's been asked by some of the other questions. So, and we kind of pursue a multi-channel approach. So like all of those rOpenSci packages, almost all of them are on the classic CRAN archive, and people discover them that way. They can also discover them through the universe. They can discover them through GitHub and GitLab. They discover them through, we have a software metadata project called CodeMeta. Many of the packages are archived on Zenodo, so they're indexed by this DataCite system. That's the global system for indexing published data with DOIs. Many of them are snapshotted by Software Heritage. So there's many lines into these packages that are aimed to serve those different communities that are used to those being their line in. And we're always trying to invent new ways. Our universe is kind of the latest take on that, trying to make it super easy to connect to discovering other packages and discovering more about the authors and the tools and the documentation that support those packages.
Thank you very much, both.
Okay, and I see an interesting taxonomy discussion going on between Brett and Abby. Carl, if you have a chance to take a look at that, be interesting to see. There's a question in there about worms being indexed, catalog of life, and what does TaxiDB cover? I don't know if you have it. Can you see that? Can you see that, Carl?
Yeah, I'm chatting with Brett and Abby. Yep.
Okay.
Yeah. For anyone else listening, yeah, worms is not directly indexed. There's some like reuse questions and direct access, but it's indexed by catalog of life. You'll see in the catalog of life list, which kind of indexes worms on about 140 other sources, and tries to sort of present them all to you. And then TaxiDB is letting you access catalog of life. So you use catalog of life in the IDs instead, but otherwise it's all there.
All right, and we're coming to the top of the hour. Megan, if you want to do one last sweep, I'm gonna just kind of quickly scan the document. I do really like the fact, and it kind of shows how our community is interlaced, that Laura mentioned Lindsay Platt, and we're hoping to have Lindsay and Nell in the January ESIP event, where we're hoping to see a little bit more coming out of the USGS Data Science and Water Lab. And then Carl, I'd also like to get your the Markdown example, because I think the USGS BBS chief would be thrilled to see that you've got that BBS fragment in your example, because that's again a program that's within USGS that we've worked with in the past, and myself and Abby, who's putting some comments in here as well, have interacted with what was the Patuxent Wildlife Research Center and the bird banding and breeding bird survey programs. So really cool. We are just about out of time. Megan, did you want to add any last minute items? Stephanie, anything you want to add? And your noise canceling headphones are doing a fantastic job. We did not hear a leaf blower.
Nothing new in the chat. Thank you, everyone.
Okay. All right, we'll bring that to a close. Top of the hour. Great timing, everyone. Carl, Laura, Stephanie, thanks so much. Fantastic presentation. Obviously, a very engaged audience. We really appreciate that, and hope to be seeing more from the rOpenSci contributors. I'm sure we're going to have a couple fellows that are going to be doing some really interesting stuff between ESIP and USGS. Thank you.
This was so much fun. Thank you so much.
Really was. Thank you.
Bye.